Mr. Benson here with a video on applications of linear graphs. So this is where we are using linear graphs to model certain things from questions that are expressed in words rather than in equations. So firstly, we need to think about an idea called dependent and independent variables, and it's just thinking about how the quantities in an equation relate to each other. Now often one thing will depend on another, so if you're doing an experiment where you're watering pumpkins, then you might expect that the pumpkins that get more water are going to get bigger. So the size of the pumpkin depends on the amount of water it's given. Now the amount of water doesn't depend on the pumpkins. The amount of water depends on, how much water you put on. So in this case, the dependent variable is the size of the pumpkin because it depends on the water, and the water is what we call an independent variable. Now in linear equations, y is the dependent variable because y always depends on x, and x is the independent variable. Just to be difficult, every so often you're going to come across some things where the one value doesn't really depend on the other one more than the opposite way around. So for example, if you're thinking about, say, the height and weight of people, it's sort of hard to say that the weight depends on the height or the height depends on the weight. So it's not always black and white, but in a lot of examples it is pretty clear. You just need to think about the logic involved. So determining the linear rules from worded problems. Now remember that a linear rule is just two numbers. It's the gradient and the y-intercept, and you've just got to think about what they mean. Now the gradient is a rate of change because it's telling you how much the line goes up or down as you move across. Now any time that you get something that is changing over time or something like that, now the really obvious examples are how much someone is paid per hour, or hiring a taxi, so how much it costs per kilometre, or when you hire lots of other things that are per hour or per day. So pretty much anything where there is a rate of something per something, you know that you're looking at the gradient. Now the y-intercept is a fixed value, so it doesn't matter how many days you hire something for or how many hours or whatever, this value is always a constant. So if you've ever hired a taxi, when you get in the taxi you pay an initial cost, and that is standard, it doesn't change, and then after that you pay for every kilometre. If you hire a car, it's the same thing. So the y-intercept is a fixed value, so always look for something in your question which is fixed, and often the values are given in the question, so the questions are actually telling you the rate and they're telling you the fixed value. Okay, for example, a plumber charges $50 call-out fee and $75 per hour. What is the cost of 3 hours work? Now the first thing I'm going to do here is find the equation of that describes the plumber's charges, and so we need to read this information and see what we can figure out. Now the first thing that leaps out at me is we've got $75 per hour, so it's a rate of change. So it's saying that for each hour the amount that we're paying will increase by 75. So immediately I've got my gradient is 75, which means the other number must be my y-intercept. But also think about what it's saying. It's a $50 call out fee, so it's a one-off fee or a fixed value. So I've got C equals 50. Now if I was going to write this in terms of x's and y's and stuff, then it would be y equals 75x plus 50. Sometimes you will write them in terms of different pronumerals as well, ones that actually make a little bit more sense to what you're doing. Now for example, we might say C for cost equals 75 T for time plus 50. Now what is the cost of 3 hours work? Basically all that's saying is that if we're thinking in terms of x and y's, x equals 3. So I've just got to substitute that into my equation, and see what I get. So $75 times 3 hours, $225, plus 50, $275 as the cost of 3 hours work. Now, sometimes you're given a pair of coordinates, so there's a number of ways you can think about the way these questions differ from each other. For one, when you get a question like the previous one, you're really only given two numbers. So you're given the $50 call-out fee and the $75 per hour. So if you're only given a couple of numbers, it's probably in the form where they're telling you the gradient and they're telling you the y-intercept. If you've got a pair of coordinates, you're going to get four numbers, and the important thing about them is that they always have a certain, they always are pairs of values, if you like. So we've got a dollar figure here and we've got a dollar figure here. We've got a number of students here and a number of students here. Now, this is also one of these times when I've got to think about what depends on what. Now, it kind of tells you this here. A tutor charges $50 for 2 students. So my money depends on the number of students and so on. Now, if I've got two coordinates, then I can calculate my gradient using the y2 minus y1 over x2 minus x1 formula. First thing I want to do though is actually figure out which is which. Now 2 students would be to the left of 4 students if I was plotting this on a Cartesian plane. So this is y1 x1 and this is y2 x2. Now note that they are written the wrong way around at the moment because my y value is before, so I'm just going to be careful in my calculations that I put them in the right place. So firstly, calculating my gradient, so y2 90 minus y1 50 over 4 minus 2, and I get 40 over 2, so I get $20 per student is my rate of change, or my gradient. So what is the cost, what's the initial fee, sorry, which is going to be the y-intercept? Well, I'm going to write down what I know so far. I'm going to choose a coordinate to use. Now these are both positive numbers, so it's both really easy. Now I'm writing my x value first, the number of students, and my y value last. I'm going to substitute this in. Oops. Should have substituted that after, and I'm going to solve, and I solve that and I find that c equals 10. So the equation here is that y, the cost the cost the tutor charges overall, is 20 times the number of students plus $10. Now the question that I've been asked here is how many students will the tutor teach for 130? So this is an example of how we can use this linear relationship to make predictions or do calculations. Now in my previous one I had an x value that I knew, and so I found the y value. In this case I've got a y value and I'm going to find the x value. So all I do is I substitute for y. So 130 equals 20x plus 10. Then I've just got to use the algebra that we've learned in the previous topic to get x by itself. So I'm going to take the 10 over the other side. So I'm going to get 120 equals 20x. Then I'm going to divide both sides by 20. They will cancel, and what I'm left with is x equals 6. So 6 students can be taught for a cost of $130.